Welcome to my pre-algebra class on Chapter 6, Section 5 on polygons. In geometry, a polygon is a closed figure formed by joining three or more line segments. So these are words that you should know. A triangle, the word tri means three sides, so this would be this symbol, this polygon, three-sided polygon. Quad means four, and looking for quadrilateral, there it is, four sides. Pentagon means five, and here we have a pentagon, five sides. Hexagon is six. Here's a six-sided figure. Heptagon means seven. Let's see which one. This is 1, 2, 3, 4, 5, 6, 7. So the arrows are heptagon. Octagon is eight sides. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be our decagon. And this thing looks like Pac-Man. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's our nonagon. And it looks like we have our nonagons here, and our octagon seems to be missing. So let's see if we can find an octagon here. Here's an octagon, eight sides. So triangle 3, quadrilateral 4, pentagon 5 sides, hexagon 6, heptagon 7, octagon 8 sides, nonagon 9, and decagon 10. If you're asked to find the size of a polygon, those are the line segments composing the polygon. So this pentagon here has line sides AB, line segment BC is a side, CD, DE, and AE. Those are the sides. The vertices are where the two line segments come together. So the vertices of this pentagon are A, B, C, D, and E. A diagonal is a line segment joining two non-consecutive vertices. So a diagonal of this pentagon, AC is a diagonal, AD is a diagonal, BE is a diagonal, BD is a diagonal, and CE are diagonals. So there were 5 diagonals. And there's a little trick to that. If you count up the number of sides here, we have 1, 2, 3, 4, 5. So from each side, starting out 8, we found 2, then 2, found these 2, and then 1. So if you have a 5-sided figure, you're going to take away 3 sides, and then you start getting your diagonals, 1, 2, because you can't count these 2 here. And then it goes the same. So if I had a 7-sided figure, it would go, take away 3, it would go 4, 4, 3, 2, and then 1. A regular polygon is a polygon made up of equal sides and equal angles. So, for example, a square is a regular polygon, has equal sides, equal angles. An equilateral triangle is a regular polygon. Pentagons that have the same, all the sides are the same length and all the angles are the same, so you could have a regular pentagon. So they have to have equal sides and equal angles. One very critical thing that you have to know in geometry is the sum of the angles of a triangle always add up to 180 degrees. And we can prove this. I have a triangle here, and I'm going to take it apart. And here are angles A, B, and C. So I'm going to start with angle C, and I'm going to take it off. Actually, it looks like I started with B. Let's try C. Take C over here. This is angle C. And I'm going to take angle B and put it next to it. And then angle A is here. Oops, that's the letter A. I'm going to turn it around and slide it over. And there's A. And the three of them together make 180 degrees. And that's true of any triangle. You can take the angles apart and they'll always add up to 180. Now we're going to use that fact to find the sum of all the angles of a polygon and diagonals. So if I take, I want to see how many, basically I want to see how many triangles I can make. So if I draw a diagonal here, I can get 2 triangles. And remember, each triangle is 180, so I have 2 times 180, so it has 360 degrees in here. If I take this pentagon and from one vertex see how many triangles I can break up inside, I have 3 of them. So there are 3 triangles, so 3 times 180 degrees for each triangle, and I get a total of 540 degrees in that polygon. And let's do one more. From one point I can make 1, 2, 3 diagonals, which gives me 4 triangles. So that's 4 times 180 degrees, which is 720 degrees. Now, what rule can we come up with that we can always use here? Well, let's figure out how many triangles we had. This is a 4-sided figure, and we ended up with 2 triangles. This was a 5-sided figure, and we ended up with 3 triangles. And this was a 1, 2, 3, 4, 5, 6-sided figure, 6 sides, and we ended up with 4 triangles. So if we look carefully, we can see a rule here. The number of triangles is always 2 less than the number of sides. So if n is the number of sides, we subtract 2. That's the number of triangles. And then we always multiply by how many degrees are in a triangle. That's 180. So here's our rule. The number of sides, take away 2, and then times by 180. That concludes the explanation for the assignment. So you need to open your book to 260. I think I'm on the wrong one here. It's 2659. And we're doing guided practice 1 to 16 and exercises 1 to 8. So you have your paper headed, paper folded in half, title, and we're ready to start. So in the guided practice, the directions are match the name of each polygon with the everyday word that has the same prefix, then give the meaning of the everyday word. So number 2, we have quadrilateral, and that would match with A, quadruple, and quad means 4, or 4 times. Problem number 4, decagon, that matches with C, decade, and a decade is 10 years, and deca always means 10. 5 through 7, evaluate the expression n minus 2 times 180, which we just figured out for each value of the variable. So number 6, the formula is n minus 2, the number of sides, take away 2 times 180 degrees for each triangle. So if we had a 9-sided figure, we take 9 minus 2, which would be 7 times 180. And if you need your calculator, use it. I seem to have misfit. Okay, so 7 times 180. So the number of degrees in this figure is 1,260. Problems 8 through 10, find the sum of the measures of the angles of each type of polygon. So number 8, we have a pentagon. A pentagon has 5 sides. So we use the formula, n minus 2, the number of sides, take away 2, gives us how many triangles we have. So 5 minus 2 is 3, and 3 times 180 is going to be 540 degrees. Number 10, an octagon, has 8 sides. So we use the formula 8 minus 2 times 180, so that would be 6 triangles are inside that octagon times 180, and 6 times 180 is 1080. So that's how many degrees are inside that shape. Numbers 11 through 13, identify each polygon and then list all of its diagonals. So number 12, let's make the figure. So this is what we have here. And this is, the shape has 3 sides, so it is definitely a triangle. And a triangle has no diagonals because all the vertices are adjacent, so there's no way to draw a diagonal. So just a triangle, no diagonals. Problem number 14, find each unknown measure. So we're going to use that rule about the number of triangles and times by 180 to find missing ones, or the sum of the angles of a triangle is 180, anything that helps us find it. So problem number 14, I'm going to again draw the figure. You don't have to, I'm just using it as a reference. So we have a triangle, this is 40 degrees, this is 110 degrees, and I'm trying to find n degrees. I know that 180 degrees makes the sum of all the angles of a triangle, so I'm going to add 40 and 110 together and subtract that from 180 to find n. So that's 150 from 180. So the missing angle is 30 degrees. Problem number 16, here's our shape. And we have, this is a right angle, this is 90. This is t degrees, it's 117, 150, and another right angle. So this is a 1, 2, 3, 4, 5-sided figure. So 5 minus 2 times 180 will give us the total number of degrees. So we have 3 times 180 degrees equals 540. So we'll add up what we have here. So it's going to be 540. To find the missing angle, add up all the ones we do have. So we have a 90. This is also 90. We have 150 and 117 degrees. So if I add those up, '90 and 90 is 180 plus 150 plus 117. I have 447. So I'll take 540 minus 447. So 540 minus 447, the missing angle T is 93 degrees. Now the exercises, we're doing 1 through 8. So problem number 2, they want us to identify the polygon. So I'll go ahead and draw it. That's what we have here. And they've made some marks on it. Whoops, I'm doing the wrong one. Sorry about that. Number 2 is not that. So let's draw number 2. It looks like this. So E, F, A, B, C, D. List all of its diagonals. I want you to actually draw the diagonals if it's possible. So I'm going to start at E, and I could get a diagonal here, and here, and here. So right now I have the following diagonals: EA, EB, and EC. Then I'm going to move to F and draw the diagonals there: FB, FC, and FD. And they're always line segments. So line segment FB, FC, and FD. Now going to A, I can get AC and AD. And then finally moving to B, I can get BD. And remember earlier I said if you took, see how many diagonals you can get total. Starting here, if you count the number of sides, you have 6. So take away 3 from 6, you should get 3, then 3, then 2, and then 1. And it worked. Okay, problem number 4. Turn the page, please. Find each unknown angle measure. So I'm going to draw the shape for 4, and then we'll find the missing angles. This is what we have. And they tell us this is a right angle, so this is 90 degrees. We're looking for M. This is 70, and this is 80. So again, we have a 4-sided figure, so we can use the formula: number of sides, take away 2, times 180 degrees gives us the total number of degrees inside. So 4 minus 2 is 2. 2 times 180 is 360. So we're going to subtract from 360 the angles we do have, which is 90 plus 80 plus 70. And we could do this in our head. That's 170 plus 70. 360 minus 240. The angle that's missing, M, is 120 degrees. Problem number 6. This one we have 1, 2, 3, 4, 5, 6 sides. And we have this side's a right angle, 90. This is 115, 120. This is 125. This is the one we're looking for, Z. And this is 156. So we have 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180. That's 4 times 180. That's 720 degrees. So add up the angles we do have. We can just use our calculator and do that right now. So we have 90 plus 115 plus 120 plus 125 plus 156. And we have a total of 606. So we're going to take 720 minus 606, and that gives us 114 degrees for Z. And the last problem, number 8. This is what our shape looks like, kind of. And we're told that this is a right angle. So this is 90, and this is Q, and this is Q, and this is Q. And since they're all the same variable, they're the same number of degrees. So we have 1, 2, 3, 4, 5, 6 sides. So it's going to be like the last one. 6 minus 2 times 180 is going to be 720 degrees. We already worked that one out. So we add what we do have given, which is 90 plus the 115 plus the 65. And that gives us a total of 270. So we're going to take 720 minus 270, which is going to be 450. Now we have 3 angles, 3 Q's have to equal the 450, and we know they're all the same, so we divide by 3, and we find out that Q, each angle Q has to be 150 degrees. That concludes the evens. Be sure you check the odds for the answers for the exercises and use that for